Welcome to section 1.7, day 1, functions. Today's objective is to determine whether a relation is a function and then find function values. Recall from yesterday, independent variables receive the input of a function. We usually use x for this independent variable, and the dependent variable changes according to what the input is. It's called the output, and we usually use y for the dependent variable. We talked about this yesterday. So today's key concept is a function. And the key piece with this is a function is a relation where each input produces exactly one output. So to be a function, each input can have only one output. Here we are going to determine whether each relation is a function. Recall from last slide that we said that to be a function, each input can only have one output. The first thing we're going to look at is a mapping diagram, or just a mapping. And we're going to look to see if each domain value only has one arrow going to a range value. And the one we show here, we have -2 only goes to -3, 0 only goes to 6, 3 only goes to 6, and 4 goes to 9. This is a function. Each domain value only has one arrow going out from it. Even though the range of 6 is shared by 0 and 3, this is still a function because each input only goes to one output. If -2 also went to 6, then because -2 would have be going to -3 and 6, it wouldn't be a function. In this case, -2 only goes to -3, 0 only goes to 6, 3 only goes to 6, and 4 only goes to 9. So we have a function. When you look at a table, you can look to see if a domain value is repeated. If a domain value is repeated and the outputs for those range values are different, then it can't be a function. In this case, we have 1 going to 4 and 1 goes to -4. So 1 has two outputs. Remember, the definition of a function says that each input can only have one output. This has two outputs for 1, so this is not a function. Lastly, we have a set of ordered pairs. Usually when you're given a set of ordered pairs, we're going to tell you to graph it or map it. But you can actually look at here again in our set of ordered pairs, look for our x values, and see if the x values repeat. Well, we have a 2 here and a 2 here, and the 2 goes to 1 here and -2 here. This is not a function. 2 has two outputs. And if you look at this, so does 3. 3 also has two outputs. 3 is going to -2 and to 1. We have two domain values that are going to different range values. So 2 has two outputs, 3 has two outputs. This is not a function. Now we have a couple more new terms to look at. One of those is what we call a discrete function. Discrete functions consist of points that are not connected. One of the ways to look at this is when we talk about units of things, like you go to the grocery store and you buy a gallon of milk. So it's coming in a gallon jug, or maybe even a half-gallon jug. You can only buy it by the jug. You can't go to the grocery store and say, I want like a half a glass of milk. They don't sell it that way. You need to buy the whole jug. If you go and buy a box of cereal, same thing. It's a unit, a whole box. You can't buy little pieces of it. These are considered discrete functions. You can only buy chunks of stuff. You can't buy every little piece of stuff. We use this for lots of different things. You have textbooks. They come in books. You can't just buy part of a book. So these are discrete. Continuous functions, when you graph them, you can graph them with an unbroken line or curve. Anything that comes in where you can get any measurement of it, one of those things would be like gasoline at the gas station. You can buy any amount of gallons. You could buy 5.32 gallons. You can buy 5.63 gallons. You can buy any amount of gas. All the numbers in between. Looking at a height of a person from the time they're born till they're full age, you are at every height in between. So that is a continuous function. Looking at the amount of rainfall that happens in your rain gauge, it's continuous. Every time a raindrop falls in there, it's going to raise how much rain you've gotten. It's a small little misty piece of rain. So these are continuous functions. So discrete functions are points that are not connected because you're talking about units of things. And continuous functions can be anywhere in between. Next, we're going to look at another way to check to see if something is a function, and it is called a vertical line test. So the vertical line test says if any vertical line passes through more than one point of the graph, the relation is not a function. If you only pass through one point, then it would be a function. But if you pass through more than one point of the graph, it's not a function. So let's look at this set of ordered pairs. We'll graph them and see if they pass the vertical line test. Let me first put in my axes. That's my y-axis. This is my x-axis. Then we're going to plot some points. So we go -4, so we go over 4 left from the origin where the x and y axes cross, and down 4. This is -4, 4. Then we're going to do -2, up 3. So 2 to the left, up 3 is right here. Then we're going to go 3 to the right, and we're at 0 on the y, so we stay right on the x-axis. And then we go -2 and down 2. And now we see if a vertical line will pass this. Well, if we put a vertical line through this graph as we go from left to right, we will run into a problem when we get to -2. Because if we put a vertical line through x is -2, we go through 2 parts or 2 points on our graph. So this first graph on the left is not a function. It does not pass the vertical line test. Because at -2, we're going to both 3 and -2. The next graph we have is y equals 2x squared plus 1. And when you graph this, you can make a table of values. So I'm going to graph this. I know how it's graphed. Later on, we're going to learn how to use a table of values to do this. I am just going to graph it. Here is the graph of 2x squared plus 1. And if you do a vertical line test on it, you will see that a vertical line will only touch the graph in one part at a time, putting a vertical line through it. This will and is a function. It passes the vertical line test. This is another tool we use to see if we have a function. We talked about mappings already. We looked at tables. We looked at set of ordered pairs, and then the vertical line test. Here it says at an ice sculpting competition, each sculptor's height was measured, and it gives the measurements where team 1 was 4 feet, team 2 was 4.5 feet, team 3 was 3.2 feet, team 4 was 5.1 feet, and team 5 was 4.8 feet. It says to make a table, then state the domain and range, determine whether it's a function, graph it, and state if it's a discrete or continuous function. So first, we are going to plug in our table. So team 1, we have team 1 through 5. And team 1 had 4 feet. Team 2 has 4.5. Team 3 was 3.2. Team 4 was 5.1. And team 5 was 4.8 feet. So we're going to look at our domain, and our domain is all of our independent, our team numbers. So 1, 2, 3, 4, and 5. And when we're looking at sets of domains, we use a curly braces to indicate they're all part of the domain. We'll do the same thing with the range. We're going to use our curly braces, and we have 4, 4.5, 3.2, 5.1, and 4.8. And we end our curly braces. So these are all our domain values. Those are our range values. It says determine whether it's a function, graph it, and state if it is discrete or continuous. We could look at our domain and range right now with our ordered pairs, and our table, I should say. And you'll see that team 1 goes to 4, team 2 goes to 4.5, 3 goes to 3.2, 4 goes to 5.1, and 5 goes to 4.8. Each team has its own height. This will be a function because each domain has only one range. Here's our table. We want to graph it. We have to do a couple things to graph this. First thing we need to do is put in our axes. All right, so with our axes, we need to label our axes. So our horizontal, our independent, we label team. Our vertical, we label height. And I'm going to put in feet and in parentheses to show that it's height in feet. When we do this, we go 1 goes to 4. 2 goes to 4.5. We'll just eyeball it, roughly 4.5. 3 goes to 3.2. 4 goes to 5.1. And 5 goes to 4.8. This is a graph of our function. The other question we have to answer is this discrete or continuous? Would we connect all these with a line between all the points or just leave them as dots? In this case, we are discrete because we have individual teams. We don't have partial teams. We don't have like 1.01 teams. We have team 1, 2, 3, 4, and 5. This is discrete, so we only graph the dots. Today we have gone through a whole bunch of information for functions, how we can figure out what a function is. Functions, for each input there is exactly one output. We can do this by looking at mapping diagrams. We can look at table of values. We can look at ordered pairs. We can use a vertical line test. We've also talked about discrete and continuous functions, like on this last slide. That is all for section 1.7, day 1, functions. Thank you for watching and have a nice day.